Okay, so we are live now, and now we will discuss in this class, in this particular session, we will discuss how to calculate or how to evaluate a double integral over a plane region. We already know how to calculate single integrals, but now we will be learning how to evaluate the double integrals. So let us look at it. Evaluating a double integral over a plane region.
So we'll jump to the examples.
First, let us build the concept, then so now we will be looking two scenarios. The first scenario is something like this. Suppose we have two functions g1x and g2. So scenario A we are discussing. Let us suppose we have two functions g1x and g2x. And these two functions are basically they are continuous on the interval a to b. It means that in this interval, closed interval a comma b, these functions they will be defined at all the points in the closed interval a comma b. There will not be any break. It is continuous. And we have a region R. We have a region R that is defined something like this. X comma y. So basically the region R will contain a coordinate like ordered pair. It is the position of the point x comma such that g1 x like such that the y in this is between g1x and g2x. Why? So the idea is that the region we are interested in, that region will always lie in between the function g1x and g2x. For all x in between a to b. Now, whatever I have stated, I will demonstrate it with a graph, then it will give us a clarity. Then we will see how to do the multiple integral. So let us make a graph of this. This is x. This is y. Now I have two functions. Let me draw those two functions.
Sir, A and B are the limits of the
A,
function.
yeah, A and B are the interval, like x.
Okay.
I have a function g1x, which I can draw something. It can be any function. It has to be continuous.
Hmm.
And I have another function that is g2x. It can be anything. It has to be continuous.
Hmm.
So both g1 and g2 should be different. So that to emphasize that both are different. That g1 and g2 are different. Any continuous function I can.
Hmm.
Now this is y is equal to g2x. This is y is equal to g2. And this is y is equal to g1. Now I have two values like x is equal to a and x is equal to b. And I have x is equal to a, x is equal to b. And I am interested in analyzing in between this a and b. So I can draw two vertical lines emphasizing. Now the region R, which we have written here. This is the region. I can highlight. Just a minute. Now we are highlighting this region. Now our multiple integral, which we will be doing now, it will be defined for this region. Because we are doing multiple integral over a plane region, and this is the plane region over which we will be doing our multiple integral.
Plane region, isn't it two-dimensional?
Yeah, it is two-dimensional plane region. It is two-dimensional. That is right. That is right. Now the double integral, what it will be, let us look at it, the formula for it. So double integral over this plane region of the function f of x comma y dA. Is visible. F of x comma dA. If we do that, how we will be doing it? It will be equal to, first we can integrate the inner function. First we can integrate the inner function. And the result of it, we can integrate with the outer function. So let us try to do that. So the integration of inner function, if we do, so we have to do it from g1x to g2x. Like first we are differentiating, first we are integrating it with respect to y, and y we can have from g1x to g2x.
Hmm.
So we are integrating the function with respect to y.
Hmm.
Whatever answer we are getting,
Hmm.
whatever answer we will get, we will integrate it with respect to x.
Hmm.
We will integrate it with respect to x.
So I've got a doubt. If you So now we are integrating with respect to two dimensions, right?
Yeah, yeah.
If you look at the graph, like the PDF that I in the PDF, there is a there is a graph where like they don't talk about the z-axis. So, but still they integrate it, and then they are, how do you say let's say I'm integrating a box or a can. So the bottom is x-axis and the height is y-axis. So how do I know the top of the like? Okay, I know
No, no,
triple A.
please. So see, just look at the title of the topic which we are discussing. Here, our focus is double integral over a plane region, and definitely three-dimensional objects also we have. We can calculate the volume of a three-dimensional object like a sphere, as you mentioned it correctly. That we will discuss later on.
Okay,
Now, yeah, because see, the idea is that whenever I am doing the double integral over a region, plane region, I am calculating the area. I am not calculating the
yeah,
volume.
with the height also, right?
No height. When I am talking about area, no height. When I
So
am talking about height,
then I can only do x-axis. I'll just do side into side and I'll find the area of a square. Why
no,
do
no,
I need?
how your function is there. The side is a function. It is not a number.
Okay, okay.
That is what we are telling. See, the idea is that now you are getting it right. If it would have been a rectangle, if
Hmm.
it would have been a rectangle, then so it was so easy, as you mentioned it very right, that oh, I know the length, I know the breadth, I will do the L into B. Exactly. But unfortunately, here we have some curve, like you can
The,
see.
the curve is basically multiple small rectangles, right? That's how we consider it to be now.
Yeah, 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 yeah,
Demands.
yeah.
So
So so
we can
so
apply that logic. Huh?
we have a region which is not symmetric, which is like some kind of a weird, the shaded region you are seeing that. Now I'm trying to find the area of that,
Okay.
and so the mathematically how I can find the area of that using this technique of multiple integral. So
Rem-
what? Yeah, yeah,
Remand,
please.
remand
Yeah, yeah,
sum.
yeah. Tell.
Are you talking about remand sum?
Yeah, yeah. Uh, yeah, but in
Small
into
rectangles and they do n number of rectangles and
so in single integral we are taking only one rectangle, like only in the one side.
yeah.
But here we have to take it both the sides.
Okay.
That is what first we are taking dy.
Uh,
So dy means we are taking this. Just
we can take anything, right? Like however we want, we can take.
yeah, yeah. Both
Okay.
both ways you like, but both ways you have to take. Order will not matter.
Yeah.
And it will extend the till here. But I'm just trying to demonstrate you that small I made this. So let us suppose this is dy.
Hmm.
Actually, it has to let me make it just so this is the dy. Let us suppose.
Hmm.
Okay. This is the d. And similarly, we also have to have dx. Like the integration. So see, when I will integrate dy, so I will get area along the one side, like the vertical side, you can say that, something like. But in order to get the total area, I have to do it along the other side also. So for that, I have to consider dx also. Because see, what is the area of the rectangle? Length into breadth. Now, this, let us suppose this is the, just let us suppose this is the, for example, let us suppose this is the breadth. Now here, breadth is not uniform because I have some curve.
Yeah.
It is varying. So exact breadth I can calculate by integrating dy. And once I did that, then length I can calculate by integrating like dx term.
Okay, got it, sir. So while we're doing dy, we keep x as constant and same way for the.
Yeah.
Okay.
This is the main idea. So this we are doing especially like to calculate the area, and definitely when you are trying to calculate the volume, then we will be having a function like z is equal to f of x comma y. We will have something like z is equal to f of x. And that we will discuss later on, how to calculate the volume. But now our focus is, we don't have a proper surface, but we have a weird surface with some weird geometry, you can say that. And we can calculate the area of that weird surface using this technique. So first we integrated with respect to y, then we integrated whatever answer we got, we integrated that with respect to x. So this is one of the scenario. In the similar way, we can discuss the second scenario. We have two functions, h1x or h1y. Now, if y is independent, like h1y, h2y, like I have a function of y, not x. So I have two functions, which is a h1 and h2, which is a function of y, for example. And both of these functions are continuous. Both of these functions are continuous functions on an interval that is c comma d, for example. Now what I will be doing, I have defined a range. I have defined a range, not range, sorry, region. We have a region like this, The region will be containing point x comma y such that h1 y, like the x, it will be lying between h1 and h2,
Hmm.
and the y, it will be between c and d.
So where is C and D?
Yeah, that I will draw. I will draw. Like for this, we will be having a different graph,
Okay, okay.
because here uh, our function is a function of y and not x. So things will reverse. So this graph will get sort of rotated. Like I can draw a fresh graph. So two axes I am drawing, x axis and y axis. Okay. Now see. Now what I will do. This is the x axis. This is the y axis. Now similarly, I have two functions, but they are the function of y. It means that for different values of y, the function will change. So
Hmm.
they will be something like this. Continuous. They have to be continuous.
Yeah.
And I can have another function. So this first function I have, I'm calling it x is equal to h1y. And I can have another function which can be anything. I'm calling it x is equal to h2. So the x will be between this, the region,
Hmm.
and the interval is from C to D.
Hmm.
That I can define. That I can define somewhere here. Let us suppose this is C. This is the interval for it.
Hmm.
Now I can draw two lines. This is the region R, and now I will shade it. Like the area we have to find. So we have to find the area of this, the shaded region. So in this scenario, what is different is that the function which is we are having, it is a function of y and not x.
Hmm.
So in order to find the area, we will use the technique of double integral.
Hmm.
So we will be doing the double integral of the function for this region R. For dA. So when we are doing the double integral,
Hmm.
first like we can integrate it with respect to x, then with respect to, that is what we do.
Hmm.
Because here it's the function of y.
Hmm.
So let us do that. I will integrate it with respect to x. So the limit will be h1y, because x is varying from h1y to h2y.
Hmm.
And we are having the function f of x comma dx.
Hmm.
Then whatever answer I will get, I will further integrate it
Hmm.
from c to d. Whatever answer I will get, I will further integrate it to c to d with respect to y.
Hmm.
So this is how we can do the multiple integration, like
Hmm.
multiple integration to compute the area of a region, and that on a plane, and that region can be any region.
Hmm.
It does not have to be symmetric,
Hmm.
as we saw, as we can see here,
Yeah.
isn't it?
Yes, sir.
Now let us look at some examples, like how to solve this to get some more clarity. So let us suppose we have to find the area, like function is given to us. Function is f of x comma y is equal to x square plus y square.
Hmm.
And the region is given. Region R is bounded by region R is bounded by
Hmm.
uh, G1x is equal to x and G2x is equal to 2x. And the interval given to us is x from 2 to 0. Now, since the interval x is changing, like x can take any value from 0 to 2, we can understand that this is a function of x. So we can solve this using the first scenario, wherein we will integrate this function with respect to y
Hmm.
and then with respect to x. Because here x is changing, like the interval x is lying between a and b. And here also in the question, we are having x from 0 to 2.
Hmm.
So first, let us convert this problem into a pictorial problem and let us solve then the integral. First, let us uh, try to look into the region. So let us draw the region. So we have two function x and 2x. And you are already aware that these are basically line, straight line.
Hmm.
So x is a basically line making 45 degree,
Hmm.
and 2x is a line somewhat like this. Now I can write it. Let us suppose this is g1x, which is equal to x itself. Let us suppose this is g2x, which is equal to- and we have been given the region. Region is from 0 to 2.
Hmm.
So let us make use of that region. This is 0.
Hmm.
Let us suppose this is 2. Let us draw a vertical line from that 2. Let me draw it properly. Now I can get the region, like I can visualize the region. This is the region we are interested in.
Hmm.
We have to find the area of this region. That's now let us evaluate it
Hmm.
using the integration method. So what we have to evaluate, we have to evaluate the double integral over the region R for the function f of x comma y
Hmm.
dA. This is what we have to calculate. And we know the formula for this is something like this. First, we will integrate the function with respect to y.
Yeah.
Then the limits will be g1 x2, g2x.
Hmm.
We will be integrating the function. We will be integrating it with respect to y.
Hmm.
And whatever answer we will get, we will integrate it with respect to x.
Hmm.
Now we will apply this technique for this question. Then we will be integrating it with respect to x. The whatever the limits are given a to b.
Hmm.
Now the formula like the answer which we will get like the solution. So first when I will integrate uh, the function that is x square plus y square
Hmm.
with respect to y.
Hmm.
Limits are x to 2x.
Hmm.
And whatever answer I will get, I will once again integrate it with respect to 0 to 2 is equal to the limit. And I will integrate it with respect to dx.
Hmm. So x to 2x is for
Yeah, yeah.
The
limits.
can you tell me the limits part alone again?
So see, the x can vary from 0 to 2. It's given.
Yeah.
Like so the outer limit will be 0 to 2. And
Hmm.
the function like we have bounded by g1x and g2x. So g1x is x and g2x is 2x. So x and 2x.
Okay, got it, got it. The two functions are from x and two functions are x and 2x. And
Yeah,
then area, okay, understood. Now I understand.
yeah, nice.
I didn't look at it that way. So yeah, now I understand.
We have integral 0 to 2. And the integration of x square plus y square with respect to dy by x will be treated as constant.
Hmm.
And constant I can take outside. So the integration will be integration of 1 is y itself. So I can write it x square y with the limit x to x plus integration of y square will be y cube by 3
Hmm.
with the limit x to x. And whatever answer like we got it, we have to integrate it with respect to x.
Hmm.
So first let us solve the limits, like put the limits and get it into an appropriate form.
Hmm.
The 2x minus x will be x. It will become x cube. Let me write it properly. See, x square we have. When I put the limit, I will get 2x minus x.
Hmm.
Less 1 by 3 I can take outside. It will become 2x ka whole cube minus x cube dx.
Hmm.
We can further simplify this.
Hmm.
0 to 2. So x into x cube or x square, it will be x cube.
Hmm.
Plus 1 by 3 into so 8 x cube minus x cube, 7x cube
Hmm.
dx. Now x cube like 1 plus 7 by 3, 3 I can take LCM.
Hmm.
So 10 by 3.
Hmm.
I will get 10 by 3 x cube.
Hmm.
Now what I will do, 10 by 3 I can take outside.
Uh, x cube, x2 by 4 by 4. Yeah.
Or I can like just, yeah, so you're right. 10 by 3 I can take outside. X to the power of 4 by 4. Limits I can,
Hmm.
that is 0 to 2.
Hmm.
Now you will get the final answer. Like 10 by 3, like 4 also I can take outside.
Hmm.
So it will be 10 by 12.
Hmm.
2 to the power of 4 minus 0.
Hmm.
So what it will be? 2 to the power of 4 is 16.
Uh,
10 into 10 by 12 into 16. So 4 3s are 4 4 40 by 3.
hmm,
This is the area.
okay.
So we calculated the area
Hmm.
of this region, shaded region, and that is 40 by 3.
Hmm. You just give me 1 minute. I'm writing it.
Yeah, please. Let me make it properly visible.
Yes, sir.
Now let us look at the next one more question. In this question, function is given. X EX. Region is given.
Hmm.
Region R. It is bounded by two functions, like two graphs. Two. Y is equal to x square and y is equal to x.
So where are you writing this? 1 second. How do I focus? Like, can you say all eyes on me? There's an option on top. Eye symbol. Okay, okay. Now I can see. Yeah. Now I.
Okay. So now this is the question. Like function is given, region is given. Like this function. Now we have to find the area. So first, let us draw the graph.
The graph we should draw, or they have given the graph also.
No, graph. No.
Is it mandatory that you're supposed to draw the
Please,
graph?
yeah, please understand.
Hmm.
See, it's your call. If you want to draw, not draw. But our goal is to understand.
Yeah, yeah. No,
Because
no. I'm asking for exam. Yeah.
yeah, see, if you can draw it, it's very good, always good. But if you feel like, oh, I don't, or
Yeah.
then
Yeah.
it's your call. But yeah, graph, you will get good visualization from understanding.
Yeah.
Yeah. Now, what we have to do? First, we have to draw y is equal to x square.
Hmm.
This is y is equal to x. Then we have to draw y is equal to x. So this graph is easy. We can draw it and hence we are drawing.
Yeah.
Okay.
Hmm.
Now this is the region whose area we have to calculate. We know that these two graphs intersect at what point that we can calculate the point of intersection of these two graphs. There x square should be equal to x. And x square is equal to x happens only in 2 points. Like x square is equal to x. It can happen only when 0, 1. When x is either 0 or then only x square will be equal to x. So here interval is not given, but we can derive it.
Hmm.
The interval for the x is 0 and
Hmm.
now we can apply that formula and solve it straight away.
Hmm.
Let us solve it straight away. Double integral of the function f of x comma y dA. Like the area we have to calculate. Let us calculate the area. It will be first. Let us integrate from x to x square and fx comma y is x dx.
Hmm.
Okay, so it is x dy square. One typo I made. Let me correct. Is x to the power of ey. Let me correct. Here also, let us do a small correction. And we have to integrate it with respect to y.
Hmm.
And whatever we will get answer,
Hmm.
that we have to further integrate with respect to x. The limit is 0 to 1 dx.
Hmm.
This is very clear to us. So first let us focus on this, the inner. Now here one interesting thing you can see that it is like multiplication of two functions.
Hmm.
So there you can apply integration by parts to solve that, isn't it?
Yes, sir.
And when you apply the integration of parts, the integration by parts, you will see that the integration of this is this itself.
Yeah, yeah, yeah. Yeah, this is a very famous thing I remember. So yeah.
Yeah. Yes. And limits we can substitute. X system. That is okay. Then we can solve this. And here one more thing we have to take care of. In the question, the region is x square, like x square x. It is bounded by that. So we have to take it. Like if the region is bounded by x square x, we have to take it that in that order. Very important observation.
Like, I didn't get it. Like, it's the same, right? What order?
So in the question it will be given bounded by y is equal to x square and y is equal to x. It means that x square to x.
Well, my question is, it can be from x squared to x or x to x square. It's all the same, right? The region won't change, right?
No, but this interval it will
But the
influence.
function, okay, the function might change.
Because in the integration it might influence. We have to be careful. So once again I am telling that they will be giving region are bounded by y is equal to x square and y is equal to x. So x square to x we have to go. That is what we are doing. Now we are done. Like just we have to put the limits. See, x is constant that we can take outside also, because limits we have to put to the y. Na? After putting limit, what you will get? You will get something like this. X e to the power of x minus x e to the power of x square. This we have to differentiate with respect to dx. And once again, we will get in the trap of integration by
but the
parts.
same thing would be coming out.
Same thing. That's same thing. So x ex, it will be x dx itself. And the limits are 0 to. What about the second function?
X e to the power y.
Yeah. What it will be?
1 second, sir. I am writing it down.
Half ex. So let me write it properly. Like after integration, what I will do. So I will get something like this. When we will integrate this x ex and x e to the power of x square dx, we will get
E to the power of x, y. No, x e to the power of x.
Yeah. So I will get finally x minus e to the power of x minus half ex square with the limit 0 to. Just let me write it properly so that it becomes visible. What we will get? Okay, 0 to 1 second. Now we can just substitute it. We can just substitute it and get the answer. Answer that you will get will be 1 by 2, 3 minus. This is the answer. Which is 3 minus e. 3 minus.
Now, if we substitute the limits, e to the power of 1 would be 0. And e to the power, so it will be 1 by 2 e to the power of e to the power 1 by 2 e. Oh, yeah, wait, yeah, I've done that. Okay. Yeah, yeah. Awesome.